of mechanical gear types and the fundamental geometric angles used in gear design. 1. Types of gears categorized by shaft orientation. Parallel shafts. Spur gears, straight teeth parallel to the shaft axis. Simple and efficient, but noisier at high speeds. Helical gears, teeth cut at an angle to the gear axis. Provide smoother, quieter operation and higher load capability than spur gears. Herringbone-Bosch double helical gears, V-shaped teeth combining two opposing helical angles to cancel out side thrust forces without extra bearings. Rack and pinion, a round gear pinion meshing with a flat-toothed bar, rack, to convert rotational motion into linear motion. Intersecting shafts. Straight bevel gears, cone-shaped gears with straight teeth, typically mounted at a 90 degrees angle. Spiral bevel gears, curved, angled teeth on a conical base for quieter operation and higher torque handling. Miter gears, a pair of identical bevel gears with a 1:1 gear ratio, used strictly to change shaft direction by 90 degrees. Non-parallel, non-intersecting shafts. Worm and worm wheel, a screw-like worm driving a gear wheel. Provides huge gear reduction ratios in a compact space and is often self-locking. Hypoid gears, similar to spiral bevel gears but with offset shaft axes. Commonly used in rear-wheel drive automotive differentials. 2. Key gear angles. Angle. Description. Typical values. Pressure angle, O alpha. The angle between the line of force transfer, line of action, and the tangent line to the pitch surface. Defines tooth strength and smoothness. 20 degrees, modern standard. 14.5 degrees, older standard. Helix angle, beta. The angle between the gear tooth trajectory and the shaft axis in helical gears. 15 degrees to 30 degrees. Pitch cone angle, delta. The angle formed between the central axis and the pitch cone line in bevel gears. 45 degrees for 1:1 miter gears. Lead angle, gamma. The angle between a thread tangent on a worm gear and the plane perpendicular to its axis. Satisfies gamma plus beta equals 90 carat circ. 5 degrees to 25 degrees. Shaft angle, sigma. The angle between the rotating axes of the driving and driven shafts. 90 degrees, most common. Of mechanical bearings categorized by their design, motion, and load handling capabilities. 1. Ball bearings, rolling contact. Ball bearings use spherical balls to reduce rotational friction. They excel at high speeds but handle lower load capacities compared to roller bearings because contact is concentrated on small points. Deep groove ball bearings, the most common type. Handles both radial, perpendicular to shaft, and light axial, parallel to shaft loads in both directions. Angular contact ball bearings, designed with offset raceways to handle heavy combined radial and axial loads at higher speeds, e.g., machine tool spindles. Thrust ball bearings, engineered purely to support axial thrust loads, forces parallel to the shaft at low to medium speeds, such as in swivel hooks or valves. Self-aligning ball bearings, features 2 rows of balls and a spherical outer raceway, allowing the bearing to automatically adjust for shaft misalignment or deflection. 2. Roller bearings, heavy load capacity. Roller bearings use cylindrical, tapered or needle-shaped elements. Because contact occurs along a line rather than a single point, they handle much higher loads than ball bearings. Cylindrical roller bearings, high radial load capacity at high speeds, commonly used in electric motors and gearboxes. Tapered roller bearings, conical rollers that handle simultaneous heavy radial and axial loads, e.g. car wheel hubs and differentials. Needle roller bearings feature thin, long cylindrical rollers. Ideal for tight compact spaces where radial space is limited, e.g. transmissions and engine rocker arms. Spherical roller bearings, double-row rollers inside a curved outer ring designed for extreme heavy loads and severe shaft misalignment, e.g. wind turbines and heavy machinery. 3. Plain bearings and specialized types. Sleeve journal bushing bearings, simple sliding contact bearings with no moving parts inside. Rely on a thin layer of lubrication, oil grease, or self-lubricating materials, bronze PTFE, to reduce friction. Linear bearings, designed for motion along a straight line rather than rotation, frequently paired with guide rails in 3D printers and CNC machines. Magnetic bearings use magnetic levitation to suspend the shaft with zero physical contact. capable of ultra-high speeds with zero wear, e.g., turbomachinery and centrifuges. Fluid B. Hydrodynamic bearings use a thin film of pressurized liquid or gas to support the load without metal-to-metal contact. Quick comparison guide. Bearing type: radial load, axial load, speed capability. Best for deep groove ball, moderate, light moderate, very high, electric motors, household appliances, cylindrical roller, high, low, high, heavy machinery drives, tapered roller, high, high, moderate, vehicle wheel bearings, gearboxes, needle roller, high, none, low moderate, compact engine components, plain Bolash sleeve, moderate, low, low moderate, high precision or low cost sliding joints. Mechanical energy from an electric motor or engine into hydraulic fluid energy flow. Important distinction: hydraulic pumps do not generate pressure on their own, they generate fluid flow. Pressure is created when that fluid encounters resistance in the system, valves, cylinders or motors. How hydraulic pumps work. Operating principle. All positive displacement hydraulic pumps operate on a simple two-step suction and discharge cycle. 1. Suction phase, inlet. Expanding internal volume creates a partial vacuum at the pump inlet, causing atmospheric pressure to force hydraulic fluid from the reservoir into the pump chamber. 2. Discharge phase, outlet. As the internal mechanism rotates or reciprocates, the chamber volume contracts, trapping the fluid and forcing it out into the system under pressure. 1. Gear pumps, simple and low cost. Gear pumps are fixed displacement pumps, move a set volume of fluid per revolution, known for their simple design, durability and low cost. External gear pumps uses two intermeshing external gears. As teeth unmesh at the inlet, oil is trapped between gear teeth and the housing, swept around the outside casing and forced out as teeth mesh again at the outlet. Internal gear pumps uses an inner gear meshing inside a larger outer ring gear, separated by a crescent-shaped seal. Highly efficient and much quieter than external gear pumps. Gerotor pumps, similar to internal gear pumps, but the inner rotor has one fewer tooth than the outer rotor, creating sealing pockets without needing a crescent spacer. 2. Vane pumps, medium pressure and quiet. Vane pumps feature a slotted rotor offset inside a cam ring housing. Slidable vanes extend outward via centrifugal force or spring pressure. Fixed displacement vane pumps. As the offset rotor turns, expanding cavities between vanes draw fluid in, while contracting cavities push fluid out through the outlet. Variable displacement vane pumps. Moving the cam ring relative to the rotor changes the chamber offset, allowing control over the volume of oil pumped per stroke without altering pump speed. 3. Piston pumps, high pressure and high efficiency. Piston pumps use reciprocating pistons inside cylinders. They handle the highest pressures, up to 700 plus bar 10,000 psi, and offer precise control. Axial piston pumps. Pistons sit parallel to the drive shaft and ride against an angled swash plate. Adjusting the swash plate angle alters piston stroke length, controlling fluid flow dynamically. Radial piston pumps. Pistons are arranged radially, star-like pattern, around an eccentric drive shaft. Extremely durable under severe loads and high pressures. Quick comparison. Pump type. Max pressure range. Noise level. Flow variability. Common applications. Gear pump. Low medium 150 to 250 bars. Higher fixed. Forklifts, tractors, log splitters. Vane pump. Medium 175 to 210 bars. Very low. Fixed or variable. Power steering, machine tools, molding. Piston pump. High 350 to 700 plus bar. Moderate, fixed or variable. Excavators, cranes, heavy industrial presses.